There has been a lot of work going around in terms of text to 3D and 4D generation of images. Recent progress in video generation models enable the synthesis of dynamic visual content with unprecedented fidelity. These advances have promoted the rapid development of techniques for 3D video generation, which use supervision from video generation models to produce animated 3D scenes, often with input conditions, for example, video, image, or text prompts. With applications including visual effects, virtual reality, and industrial design, realistic and controllable generation of 4D content has broad potential impact. This is a new paper, TC4D, which has been present on Hugging Face. They also have this GitHub repo, this project page, and a lot of other stuff, which I will drop the link in video's description. The thing is that methods for 4D generation show immense promise, but they are yet limited in quality and realism of synthesized motion effects. Specifically, these methods animate a volumetric scene representation via learned deformation or appearances changes predicted by a neural representation or even generative model. Since the scene is confined to a particular region, for example, a 3D bounding box containing the volumetric representation, the synthesized motion is highly local, and the magnitude of motion is typically much smaller than the scale of the scene itself. For example, existing techniques can synthesize characters that walk in place, gesticulate, or sway, but they cannot move around a scene or exhibit global motion effects in general. That is where they have come up with this new technique. They consider the specific problem of text to 4D generation with both local and global motion, where global motions occur at scales larger than the bounding box of an object. If you go through their project page, you will see a lot of examples. For example, if you look here, and I would need to reload maybe because this is a bit heavy. My apologies. I'm reloading this page. You can see here it is working now. Now, as existing architectures are incompatible with synthesizing global motions, we actually require a new motion representation that facilitates learning motion at coarse and fine scales. And we require a solution that decouples the temporal resolution and duration of generated 4D scenes from the output size constraints of the video generation model used for supervision. And that is where they propose this TC4D, which stands for Trajectory Conditioned Text to 4D Generation, which factors motion into global and local component. They represent the global motion of a scene's bounding box using rigid transformation along a trajectory parameterized by a spline. They also learn local deformations that conform to the global trajectory using supervision from a text to video model. Their approach enables the synthesis of scenes animated along arbitrary trajectories, compositional scenes generation, and significantly improvements to the realism and amount of generated motion, which they evaluate qualitatively and through a user study. And there are a lot of examples as you can see on your screen. Let me show you a few of the examples from their paper. If you look at this image, these are the scenes generated using TC4D or trajectory conditioned 4D generation. They show scenes consisting of multiple dynamic objects generated with text prompts and composited together. The scene is shown for different viewpoints or panels and at different time steps in the horizontal dimension. Motion is synthesized by animating the scene's bounding box along a provided trajectory using a rigid transformation, and they optimize for local deformations that are consistent with the trajectory using supervision from a video diffusion model. Overall, their approach improves the amount and realism of motion in generated 4D scenes. If you look at this example here, this is just an overview of TC4D. The method takes as input a pre-trained 3D scene generated using supervision from a 2D and 3D diffusion model. Then they animate the scene through a decomposition of motion at global and local scales. Motion at a global scale is incorporated via a rigid transformation of the bounding box containing the object representation along a given spline trajectory. Then they align local motion to the trajectory by optimizing a separate deformation model that warps the underlying volumetric representation based on supervision from a text to video model. The output is an animated 3D scene with motion that is more realistic and greater in magnitude than previous technique. Let's look at another example. This is where we are comparing text to video and text to 4D generation. Existing methods for video generation such as Video Crafter 2, and I believe I also covered this few days ago in another video. Video Crafter 2 create realistic object with motion at both global and local scale. For example, a generated unicorn or corgi moves across the camera field of view, which is global motion, in concert with the animation of its legs and body, which is the local motion. But existing text to 4D methods only generate a limited amount of motion on the spot and do not learn global motion in 3D space. Now, if you go to this project page, you can already see all what we have just discussed in motion. So all in all, this work takes important steps in making motion synthesis for text to 4D models more realistic and expressive. And this framework enables scene scale motion of entities within compositional 4D scenes with trajectory conditioning, achieving meaningful improvement over prior works that show motions at fixed locations. The proposed factorized motion model opens several avenues for future work. I, th- I think, and they have also mentioned it in the paper that they also foresee extensions to generate scenes with multiple interacting objects, adding motions to existing in the wild 3D assets, and also synthesis of motion across unbounded large scale scenes. And I believe that this approach can automatically generate realistic animated 3D scenes. Such techniques can be misused to promulgate realistic fake content for the purpose of misinformation. So that is where I think there should be and there must be some regulation and some guardrails in place. That's it, guys. I will drop the link to this project page in video's description. Go through it. Let me know what do you think. Really hats off to all of these researchers. They have done wonderful job here. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.